Welcome everybody to this webinar here on SvanNET AI, made jointly by Svantek Poland and Svantek UK. I can still see on my interface here that we have a lot of people settling in, so thank you very much for joining us this afternoon, and I hope I will be able to provide some good information about what we have in store for you all today in terms of new functionalities in SvanNet. So I think without further ado, we're just gonna get started, and the few first slides are not that important for the whole picture of today's presentation. So I'll start by introducing myself. My name is Adam Marczak, and I'm the Associate Sales Director at Svantek. I work with Svantek UK, and my background is within acoustics. I've studied applied acoustics at the University of Chalmers in Gothenburg, and my job here at Svantek is to sell and teach about the products that we have. What we have for you guys in store today is a webinar that consists of 4 parts. We're just gonna go through a few words and slides about the company, about Svantek. We might have some people joining us that do not have the knowledge and background of who we are as a company. And then we're just gonna go straight into the AI concept. So we'll start by explaining a little bit about what the SvanNet AI really is and what it does, why we try to create something that we think is going to bring a lot of value to our customers in the future. And then I'm going to show you how to actually apply it. So using it on the current platform, using the SvanNet AI, which is in its beta mode, on SvanNet. And last but not least, we're going to talk a little bit about a future development. So what we're planning to add to the AI module, what we're planning to do to make this AI revolution even better for our customers, future and current. So, Svantek. Svantek is a company that was established in 1990, and we focus on one thing and one thing only: sound and vibration. So the acoustic world, where we have been working on providing the best tools for measurement of the highest reliability and accuracy ever since the 1990s. We have an in-house R&D department, we have an in-house production department. All of Svantek elements and devices that you'll have shipped to you if you're a client now or will be in the future will have been hand assembled here in our factory as shown on this picture. The philosophy of Svantek is to continue improving, to always add new innovations into the market, and this is something that we've been very successful in doing with example the 307A, which is the first and only class 1 type approved MEMS-based sound level meter on the market. The company consists today of 185 full-time employees, which ranges from assemblymen on the production line to R&D department engineers doing firmware, hardware, or software development within our company. The company is based out of Warsaw, Poland, and here we have our main production department with a mechanical shop just a few kilometers away where we do most of our mechanical parts. Thanks to this, keeping all of this in-house, we're able to fast and quickly adapt to the situations and to new outcomes in the markets and create bespoke solutions for our customers, making sure that they get the best product and they get it fast. The devices that we manufacture are ranging within 4 different categories. The main one that we will be focusing on today is noise monitoring. For you that don't know, as I mentioned, we have the only class 1 MEMS type approved noise monitoring station, the 307A, but we were also the first to develop a device with noise directivity, which is the 200A. On top of that, we have our advanced handheld range, the sound and vibration analyzers. These are interchangeable with the noise monitoring stations, as we also have Pelicase stations where handheld noise analyzers or vibration analyzers are used as permanent or semi-permanent solutions. We also have vibration monitoring, and while the AI revolution will come to that, the vibration monitoring and how to qualify vibrations based on AI, this is not the subject of today's presentation and webinar. This is something that we will cover in the future. On top of that, we are very proud to have a very strong health and safety and industrial hygiene line with noise and vibration dosimeters. Svantek noise and vibration dosimeters have been used worldwide and even above, where we're currently working on a European Space Agency project to put even more Svantek equipment on the ISS, which is the International Space Station. Svantek has been the proud provider of the noise monitoring on the International Space Station since 2016 with the Svantek SV102A Plus, a dual channel class 1 noise dosimeter, but we will now be taking it further with a next step to a wireless revolution on board of the ISS, where our devices will be able to interact and communicate with the onboard computer that gathers all the information about the well-being of the astronauts on board. So those are the four major segments that we have within this company. And in order to be able to grow this company and keep on innovating, we had to go global. Today, Svantek is represented in over 70 countries worldwide, with partners and subsidiaries spread out the world. In the UK, we're represented by the great Svantek UK, which not only provides pre and post sale support, but can also do service, calibration, and R&D efforts, making sure that we create the best product for the UK market. Now that was a little bit about Svantek, and I will not take more time to talk about that because that's not what we came here for. What we're here for is to talk about the SvanNET AI and the AI revolution. Understanding the concept and the need is going to be first here on this presentation. So at Svantek, we decided that with the whole AI revolution, which we've seen lately, it is very important to enable the ability to fast and easy identify different noise sources. Now, as you know, we're all heading towards the smart city applications. We're heading towards applications where we want everything automated, we want everything fast, and we want everything cheap. Now, with noise, this has always been a problem. Class 1 accuracy is required by regulators and should be because that gives you the best ability to ensure that the data you're gathering is actually reliable. While a 0.5 dB difference might seem like something small, we gotta remember that this is a logarithmic scale. On the higher dynamics, 0.5 dB can be very, very much. This is a topic for a different webinar, but we should never compromise on quality and accuracy of measurements. On top of that, what we thought we need to create was the ability to easily deploy a station and measure for a type of noise. For example, if you're measuring construction noise on a train station, you do not want to get alarms or exceedances if somebody screams next to the microphone or uses the honk. So how can we do that? Well, AI is the only tool. When we started this AI revolution 2 years ago, we created a team. Two full-time AI engineers engaged to build the best AI for noise source recognition at our company. On top of that, the current software engineers that we have here who are supporting the establishment of this new AI module and hosting it on the existing platforms SvanNet for online, SvanPC++ for offline post-processing. On top of that, we took help by professional acoustic consultants who contributed with their work, with their input, and especially with their data to be able to train the model when data was obtained using Svantek equipment. And then finally, we would never be where we are right now if we didn't have a small army of student interns and workers that could validate all of the recordings that we made and make sure that the AI is correctly tagging and responding to those different inputs. All of that work has led to 11,500 open source noise files that we had to tag and use to train the model. Svantek itself obtained and created over 8,760 files, which we then used and tagged to be able to train the model. So the model is not just taken from some generic inputs from the web where you download YouTube video files with a cat yawning and then tag that as a cat. No, a lot of these inputs, sources that we use to train the model were actually from Svantek equipment measured out in the field to be able to best give you the confidence that you need. So over 730,000 samples were used to be able to train the model that we have today. And that gave us something which we're very proud of. It gives us an AI model that has 27 unique classes, and these are their icons. So we can have everything from aviation noise on an airplane drone noise, which is highly popular right now due to a range of reasons from warfare to also airplane and aviation industry, motorcycles, construction, wind, vehicle horn, vehicle alarms. All of those things are unique noise classes that can be tagged within our AI model. And this is not to say that we stop the work there, because we are open to your suggestions and to your input of what we should have next. Now, the next slide, I'm not gonna lie, is the toughest on this whole presentation. The next slide is a slide that was, let's say, I was taught to be able to present. Step one in classifying the wave using AI is very easy. You need to obtain a wave file. So in other words, you need an audio file. You need an audio file that is triggered based on something. We do not want you to trigger on a background noise, because if the signal to noise ratio, so the noise, or you should call it maybe background noise, is as high as the class you're trying to capture, you will not be able to get anything out of this. But so the source you're trying to tag, the source you're trying to classify, should at least be 3 dB higher than the background noise that you're currently measuring with. It's not a rule, it's not a requirement, it's a recommendation to get the most out of this. Now, step two is qualify as a noise class. And this is, again, something that I will read out to you, and apologies for that. Nobody likes somebody that reads straight from the slide. But I will also try to explain what I think that means. So what we do after we've obtained the WAV file is that we qualify that as a noise class through performing a depth-wise separable convolution to filter and identify specific patterns in the sound data. After this, a neural network checks each possible noise class against the process data. This occurs every 0.48 seconds and gives us a probability score for each noise class, helping to determine the most likely source of data. All right, that's the text. Now, what does that mean? Well, still, we can't oversimplify it as I was taught by these AI scientists, but we can try to give an idea of the process. The depth-wise separable convolution takes the WAV file, which is very big, very rich in data, but in a lot of data that we don't need, and filters out or selects out all of those parts that are necessary for us to be able to use our model to classify. So we take something very big, and using the depth-wise separable convolution, we take only what we really need. Then we send it into our gated recurrent unit, which is the model, the neural network, that then looks at that depth-wise separable convoluted file or data, right, from the original WAV file, and looks at that, and then using its neural network, it checks that for each and every one of the classes. So it takes that pattern, it takes that depth-wise separable convoluted file and checks, is this a cat? 1% possibility that this is a cat. Is this a train? Maybe not. Is this an airplane? 90% probability. Well, maybe this is indeed an airplane. So what we're trying to do here using our model is to see what is the biggest chance of this matching our model that we taught our AI to follow. That is what we need to do, because in the end, what the output of the SvanNET AI is to qualify the noise that you obtain with the highest confidence possible. So let me walk you through the concept of confidence. In SvanNet, right now, we have 3 levels of confidence. If something is between 57 to 78% of confidence, we will tag it with this red little tag of low confidence. If something is between 78 to 98% confident, that our model is confident at even a 98% grade, that this is something that it thinks should be classed as a dog, as a cat, as a train, then we will give it a medium confidence. If we have something called at a 99 or higher, then we will get a high confidence. And I know this doesn't make much sense right now. So what I'm going to try to do right now is I'm going to try to show you different examples of high and low confidence. Now, something that I mentioned very briefly is that this occurs at every half second. So every half second, our SvanNET AI will check the latest data and it will try to tell what was the most dominant part for each and every one of these half-second samples. So please bear with me looking at this graph. This is a graph of our model trying to quantify a 40-second measurement recording and find one class that it could show it as. As you can see here in black, the train horn comes up in the beginning, in the end, birds in the middle, and train in the absolute middle. Now, this is to show you that if you have a too long file, we can only give you one noise class. So if you have a 40-second file where you have 3 different dominant noise classes within the noise classes that we can give you, you will not be able to distinguish what is the most dominant. Now I'm gonna try to play this up to you guys, the audio file, because this, so that you can follow it, but be aware, this is a very low file, you can't hear it very well. So try to hear it as well as you can. I'm gonna play it now. Okay, I don't know how well you could hear that. We can stop it at this. But what you should have heard at one point was the loud horn. A very loud horn which can be seen in the middle here with the black peak. Then straight after that horn dies out, we actually classify the next noise as train. So what we have here is a lot of dominant sources with a lot of high probability, but at a very long file, meaning that we have a lot of noise classes fighting each other. So what happened? Well, we classified this as a train horn with low confidence. Because this is a two-step process, we do not only look at the AI model's output in terms of certainty, but we also look at the LAQ, at the noise levels, at the different types of sound metrics that the sound station also measures. Look at the uh, unsolid line that you can see there maybe in gray. That is the LAQ level. So we will not only look at the confidence of that, we will also look at the LAQ to get a full picture of the noise measured. Now let's take a look at the next one. The next one is a medium certainty. Now take a look at this with me. Between 0 to 5 seconds, we got a very high confidence that this is a motorcycle, but the longer this file goes, the lower that confidence is. Now, the longer the measurement goes, the higher is the certainty that this is indeed a vehicle and not a motorcycle. So we have two dominant noise sources, both fighting for the classing. So I'm gonna play that sound now, and we're gonna try to listen to that together and see what that difference is. So let's do this right here. So a very short recording indeed. Now again, take a look at the non-solid line in the background in the gray. What you can see on the non-solid line is that when the LAQ level was the highest, that's when we had the highest or a high probability that this is a motorcycle. So what did the AI model do? It identified it as a motorcycle. Now, how do we get that 98 super high confidence? Well, enter the last example in this piece, the high probability matrix. Now this, we're gonna see if you can guess what that was qualified as. So let's listen to this together. As you might have understood, this was indeed a dog. Now you can ask yourself, Adam, you told us that the confidence level needs to be 98% or higher for a green mark of a high confidence. Now remember, this is a two-step process. The model gives you a confidence level based on the wave recording alone, but but then it correlates that data to the noise pressure or sound pressure level, to the actual noise metrics. And when it sees that every time it's confident that we have a dog, and every time the dog actually barks, we have a high LAQ, it adds on to that confidence, increasing it and then tagging it as a dog with high confidence. This is the way it works on our model. So what are the real life applications for this? This is actually a project that is ongoing in New York City, which is very interesting, an MTA project where they are taking apart old subway stations in downtown Manhattan, and they are renovating them. They are not in good shape and need to be renovated. The problem is that there is a very strict and regulated noise limit that the construction workers need to adhere to. So how do you adhere to a strong and very well defined noise limit when you at the same time have people laughing, screaming, and shouting within the train station, but even worse, you have actual trains passing by creating very high noise? Well, you have two options. Either you listen through all exceedances and manually tag them valid or invalid noise, or you use the AI solution. Using the AI solution, you could filter out all the noises that do not interest you and filter all the noises that do interest you. And then with very little manual labor that we're hoping that we can, in short, also automate, you would be able to distinguish what noise limits were actually exceeded based on what caused those noise exposures. This is one of the real life applications. So for all of our clients that already have SvanNet equipment and Svantek equipment and SvanNet as a platform, how do you get about using this? Well, let me walk you through the few last slides so that you can start playing around with it on your own. The first requirement is to have a supported meter. Currently, this is supported on the 307, 307A, the 200A, and the 977/277 if used in a Pele case. So either one of these devices will work. However, there are some other requirements apart from the supported meters. Number two is you have to have SvanNet projects. So SvanNet comes in two modules, one that is free of charge and one that is based on a subscription model that is still one of the cheapest in the industry. You do need to have a SvanNet project as all of this AI is done in the cloud. Thirdly, you do need a recording option at this time. So you need to be able to trigger wave recordings so that you can then use those wave recordings as the source for noise classification. And final, you need to accept the terms and conditions. SvanNet AI is in beta, and you need to be aware that errors can still occur. Now, when you have all of that, all you need to do is select a suitable threshold. As I mentioned before, you need to select the threshold for the wave to be triggered that is at least 3 dB higher than the dominant or the constant background noise. Otherwise, you'll end up triggering a bunch of wave files. Each wave file is going to have different classes of different confidence, and you'll end up with a bunch of red files, all with low confidence, trying to distinguish between wind and other nature noises. So that is one thing that you must set up in all of your devices. Number two is that we need sufficient quality of that data. 24 kilohertz of sampling or higher is required for this to properly work. Otherwise, we undersample and the model cannot get what it needs. So this is also a setting that you can set up in all of our devices, making sure that they obtain data with the correct sampling rate. Now, finally, you need to accept in the configuration part of the project on SvanNet the terms and conditions. You do that by clicking the AI icon next to the station configuration. Now that will trigger a small dialog box where you will have some text. In that text, you need to click and accept, and then you will have a green little square instead of a blue one, indicating that the AI is now activated for that measurement point. And finally, in SvanNet, the best way to look at this is in the event view. So here's a very short presentation of how that will look like. So within the project, after you scroll down, you find your event view, and here you have your noise class and the confidence level. Now the confidence level is also shown graphically. You can, of course, go into each and every one of these events and mark them to get a more detailed view, to see the time history chart, which time and which alarm was triggered, and then finally you can also listen to that recording, making sure that it is indeed music. Now, if you are happy with the tagging, we always ask for feedback. So feedback of giving a green thumbs up is going to give us even more input to our model, making sure this model is even better. This is something that is important to us, especially in the beta stage. For each and every one of these noise classes, you can give the thumbs up to indicate a good tagging and a thumbs down to indicate a bad tagging. With the thumbs down function, you will always be asked to specify what kind of source it was, because sometimes it's too hard to distinguish yourself, but we are very thankful if that is being done. Of course, you do not have to define that. You can just give that thumbs down as you like to. Now, I promise that the last part of this segment would be the future development. The future is very exciting when it comes to AI. There's so much you can do. There's so much more that can be achieved. Now, currently, we are in the stage where the AI beta was released on SvanNet. It is completely free of charge for all SvanNet subscription users up until the end of this year, after which we will probably try to make this into some kind of paid module, as it is indeed required to be able to finance this through and host it on the Azure cloud that we're using. SvanPC++, however, will also have an AI module, and this is already in prototype stage, will be released very shortly, so that you can do post-processing and AI classification of offline files, not in real time, but in the post-processing stage of your data handling. And then finally, the future development. The future development, as I mentioned, is very interesting. Future development will include using third octave band analysis that will allow us to not only trigger the AA module on certain exceedances, but will allow us to have a continuous classification of noise. Imagine how interesting that could be when you are able to classify a noise source over the entire course of a measurement period. Now, uploading WAV files to the cloud is both data hungry and storage hungry, but third octave band spectrums are not that big of a deal. So what we're planning to do is to enable the user to tell that at this point, in this particular position, we were able to distinguish that 90 or 85% of the noise was caused by traffic, while 10% of the noise was caused by aviation. This is development that will take place on SvanNet and at Svantek, and we're very excited to have you as part of this journey. So, with that being said, I'd like to thank you all for your participation. We're 1 minute off schedule, for which I apologize, and we encourage all of you to send your questions to sales@svantek.co.uk. We will be with you as soon as we can to schedule a demo or answer any questions that you might have. So thank you very much for your attention. This has been a great pleasure. And if you have any questions, let us know.